evaluate the integral cos square 2x dx. So when it is raised to power 2, it is easier to use a concept of a double angle, isn't it? So when it is raised to power 3 going onwards, is when you now use the de Moivre's theorem. Power 2, you simply go to double angle direct. Are we together? So here you say, you have, when you have cos theta plus theta, that was cos square theta minus sin square theta. So theta plus theta, remember, is what? Is 2 theta, isn't it? That is a double angle. But we want cos square, meaning we make everything here in terms of cos square, isn't it? Are we together? So what is sin square? From Pythagorean identity. From Pythagorean identity, sin square theta plus, from Pythagorean identity, you have sin square theta plus cos square theta is equals to 1, isn't it? So it means sin square theta is 1 minus cos square, isn't it? Are we together? Yeah. So where you have sin square theta, you put 1 minus cos square theta from the Pythagorean identity. Okay? So after that, you now collect, when you open this bracket, cos square theta minus into minus is plus, isn't it? So there you get 2 cos square theta minus 1, isn't it? Are we together? Yeah. Then this side we have cos 2. But what do we want to make the subject? Cos square theta, isn't it? So for you to make cos square theta the subject, you bring negative 1 this side. So you have 2 cos square theta is 1 plus cos 2 theta, isn't it? Then you divide both sides of the equation by 2. So you get a half plus a half cos 2. Are we together? Are we together? So you see, you've gotten rid of the power of the cos, meaning cos square theta is a half plus a half cos 2 theta. So cos square theta, meaning what is your theta? Your theta is 2. What is your theta? 2x, because it is cos square theta, meaning theta is 2x, cos square theta. Theta is 2. So where there is theta, you put 2x, isn't it? Are we together? Where there is theta, you put 2x, so it means cos square 2x is equals to a half plus a half cos 4x, because theta is 2x, so 2 times 2x you get 4x, isn't it? Are we together? Tuko pamoja? So when it is raised to power 2, you simply use the concept of the double angle alongside the Pythagorean identity, isn't it? You don't go to de Moivre's theorem, because de Moivre's theorem will involve binomial expansion, which is a long process in something which is very simple, isn't it? You only go to de Moivre's theorem when it is power 3 and above. Are we in agreement there? Good. So you come here and you substitute, you found that in cos square 2x, which is this, is the same as a half plus a half cos 4x. So you see, a half is a common factor. You can factorize a half outside, then inside you remain with 1 plus cos 4x, because a half is a common factor, isn't it? So if you factorize a half outside, inside you remain with 1 plus cos 4x dx. So it means the old problem, which was cos square 2x dx, you can now integrate it, meaning you've used the concept of double angle to get rid of the power, meaning cos square 2x is the same as this. Is that okay? Are we together? So can you now start integrating? We have a half outside. If you integrate 1, what do you get? So you get x, because 1 means x raised to power 0. Anything raised to power 0 is 1, isn't it? So if you integrate x raised to power 0, so you simply add 1 to the power and you divide by the certain power, polynomial, isn't it? Are we together? Thank you. Then you go to the next one, plus, if you integrate cos, don't check what, first of all, the derivative of inner function must be a constant. The inner function is 4x. If you differentiate 4x, you get 4, isn't it? So it means you can integrate it, isn't it? When you differentiate cos, you are getting negative sign, meaning if you integrate cos, you are getting positive sign, isn't it? So here we have plus sine 4x, then you divide by derivative of the inner function, isn't it? What is the derivative of the inner function? 4. Good. Then at the end of integration, you add a arbitrary integration constant if you don't have the limits of integration. That is a case of an indefinite integral. Are we together there? So you simply, you are asked to simplify it further if you like. So a half times x is a half x plus a half times this is a half times 1 over 4 is 1 over 8, isn't it? So this is 1 over 4. 1 over 8 sine 4x plus c. But not all of you we'll find it in this manner. Somebody might have used another method and found something different from this because it is indefinite. So the moment it is definite, the moment they give you limit, all of you will get the same answer. Are we together?